We saw in problems 1 and 2 where we had both x and y already as additive inverses. But when we move into the next problems, 3 and 4, we do not have additive inverses and we need to create them. To create additive inverses, we always use multiplication. So first thing we need to do is pick. Do you want to choose to eliminate x's or choose to eliminate y's? There's never a right answer or a wrong answer. It's about what you see to be the easier way to do this problem. So that let's do number 3 by eliminating x's. When we look at x's to eliminate them, we would want them both to be 3's, negative 3x and positive 3x. To make that happen with multiplication, we need to take this top equation and we need to multiply both the left of the equal sign and the right of the equal sign by the same number, and in this case that's a 3. On the top, that's a distribution, so I'm going to draw a big line so I know that I'm looking at a different set of problems here. Negative x times 3 gives me negative 3x. 3 times y gives me plus 3y is equal to negative 10 times 3 is negative 30. The bottom equation we don't want to change, so technically we multiply it by a 1, but we don't even need to write that. We just need to copy it down again so it's in our lineup. I forgot to note it when I started this problem because to my eyes it was very obvious, but the order of these problems was just fine. We had standard form. We didn't need to reorganize anything in order to do this problem. Then I created my additive inverses, which I now have. Negative 3x and positive 3x add to 0. So I'm going to take my two equations and add them together, or perform the elimination. Negative 3x and positive 3x added together make 0. 3y and 1y make 4y equal to negative 30 plus 2 is negative 28. Divide both sides by 4, and we get y is equal to negative 7. Remember, that's never enough information in Chapter 7. We have to have our full answer. So you take it back up here, wherever there is both an x and a y, and you plug it in, whichever one you think looks the easiest. I'm going to choose the first equation. Negative x plus y, so plus negative 7, is equal to negative 10. I'm solving, so I will add 7 to both sides. Negative 7 plus 7 gives me 0. So that negative x, or the opposite of x, is equal to negative 3. And if the opposite of x is negative 3, then x itself is actually positive 3. And my solution, the point where these two lines cross, has an x value of 3 and a y value of negative 7. I want you to see that one again. This time I'm going to choose to eliminate the y values. All right, so what would I do so that my y values would eliminate? Well, I could turn 5y and I could also turn 2y. I could turn them both into 10y pretty easily. So that's what I'm going to do. I will take the first equation, and to get it to be positive 10y, I would need to multiply that by 2. So my first equation is going to change. I need to do a distributive property on the left. So that's 4x plus 10y equals 32. And the second equation, I want the y values is what I chose to eliminate. So I need to multiply this one by 5. I need to double check. It doesn't need to be a negative, right? No, because when I multiply, then I'll have a negative 10y and I'll be okay. So distribute. That's 25x minus 10y is equal to 55. I have my additive inverses, so I can add my two equations together. There's my elimination, they add to 0. So I end up with 29x equals 87. Divide both sides by 29. X is equal to 3. You can use your calculator, but they tend to work out pretty easily. Once I have an x value, I can take it all the way back up, plug it in wherever I see both x and y and think it looks pretty easy. I'm going to use the second equation this time because I can. 5 times 3 minus 2, oops, that should be a y, not a parentheses, is equal to, oops, not 55, but 11. Let's clean this up. And finish solving. Okay, number 5. The first thing I'm hoping you're seeing is that this is a situation where your eyes should look at it and go, whoa, something's not quite right. And when that happens, you say, oh, okay, I just need to adjust the order. That means that the x value in this case needs to go to the other side of the equal sign. So to do that, we're just going to add 6x to both sides. So that our new equations now look like this. 6x plus 5y is equal to 4. And the second one I didn't need to change at all. It was in a good format. 6x minus 7y is equal to negative 20. Do I have additive inverses? Which ones are going to be easier to make, x's or y's? Hopefully you said no, we don't have additive inverses, and hopefully you see that changing 6x and making the x terms be additive inverses is the easier method. You simply need to choose which one you would like to multiply. It doesn't matter which one, and hopefully you see that the bottom one is the easier one. Again, it's not going to matter. You could just as easily have chosen to eliminate y's here. It's just not as easy. We're going to take that second equation and multiply it by a negative 1. So that I now have, I didn't do anything to the first equation, 6x plus 5y is equal to 4, and negative 6x plus 7y is equal to positive 20. Once I have my additive inverses, then I can use my elimination and add my two equations together. I think you're pretty comfortable, so I'm not going to talk you through the rest of the solving. To get to your solution, these two lines cross at the point negative 1, 2. I will tell you that number 6 is a special case, but I'd also like you to get it started and see how far you can go on your own. Remember that it doesn't matter whether you eliminate x's or y's. Push pause, give it a try. So here's where the special case happens. regardless of what you chose to eliminate, both your x terms and your y terms actually eliminate. With this type of format, you're only allowed to eliminate one variable. The other one you have to actually add together. Or you could really think of this as 0 plus 0. We have to have something on the left side of the equal sign. So if they both eliminate, that left side, is always going to be 0. On the right-hand side, you need to be very careful with your addition. Sometimes it'll work and sometimes it doesn't work. In this case, negative 10 plus 7, that's negative 3. 0 is never equal to negative 3. Makes this problem a no solutions problem. These two lines are parallel. They will never touch. They do not have any common points. If we got to the bottom of that problem and had a true statement, such as 0 equal to 0, that's when we would know we had the same lines and our answers would be infinitely many.